Ladies and gentlemen, the arrogant worms. Now right now I'm using my cell phone to run an app called Volumio. Well, actually, the cell phone is just running a web interface, and I've got a Raspberry Pi running Volumio. And it's over here, and it's going to help us take a look at some of the audio circuits that we're going to be building. I've got some speakers here and a breadboard all set up. We've got the transformer and the power supply that you've built, not inside a case. This is a Raspberry Pi. That's a Pi Zero, a fairly inexpensive one. Connect to a USB hub with a Wi-Fi dongle, sound card, and our breadboard is got a color organ on it, a couple of left and right channels on here, and an amplifier. And we're going to talk about speakers and what sound is for a little bit. And what we've got is we've got an audio source right here. If I unplug, it goes quiet for a little bit. And you could plug this into your cell phone or just about any audio source that you wanted. And it comes in right here. Now, your cell phone or whatever audio source you're using doesn't have enough power to actually run a speaker. Little speaker like that, let alone bigger speakers or even bigger speakers. Or bigger speakers. That's what we need amplifiers for. And we're going to talk about amplifiers quite a bit, but before we do, let's talk about what sound is. How is sound getting from the speaker or my voice up to the cell phone, and then how is it being recorded, and how are you listening to it right now? Well, sound is vibrations, and when I put my hand on this speaker, I can feel it vibrating back and forth. And if I go to a slightly bigger speaker, let me just unplug this one here. I did a really good job of plugging that in. Excuse me, and let's go up to a 3-inch diameter speaker. Ooh, that's a bit louder. And let me crank the volume here a bit. Ooh, I might be distorting things a little bit. I've got a little piece of paper here wrapped up, and it wasn't supposed to fall down there. There we go. Woo. Try to keep that in the middle. I don't need that much volume. So what we've got going on there is that's showing you visually what sound is. When it's a little quieter, we're not vibrating that speaker as much. When we've got high-pitched notes, we're vibrating the speaker really rapidly. And when we've got lower-pitched notes, we're vibrating the speaker more slowly. Now, if we go up to a bigger speaker, let's take this one in right here. You can see that again, and here you can actually, if you're close up enough to it, you can actually see the speaker itself doing a little bit of vibrating. And let me pull up another song right here. You can hear a bit of noise in the background. That's unwanted noise. We try to get rid of that in our amplifier circuits. And
I used to be a farmer
this one's got a much bigger woofer on it. So it's really much better at delivering the bass sounds because you've got a big speaker moving back and forth, moving a lot of air. And you can put your hand on that and really feel it vibrating. And of course, you can plug just about any speaker into this little amplifier chip right here, and it'll do its darndest to power them. And here I've got a nice enclosed speaker, and you're going to hear hopefully it's going to come through a little bit of an improved sound when we hook this up. It's supposed to sound like that. They're saying, "Ah, they're pirates."
It's a hook.
I can still hear a little bit of noise coming through in the background. Definitely better bass coming out of the enclosed speaker. Now, why do some speakers generate better sounds than others? Well, a lot of that has to do with how they manage these vibrations that go through the air. And so on your big bad breadboard board, you've got a little speaker like this, and we've got it mounted just with a little cover on here, right onto your board. And it doesn't sound that hot, but try wrapping your hand around it. And all of a sudden your sound quality is going to improve a lot. That's because not only is this sending sound vibrations upwards, but it's sending sound vibrations downwards. And when those sound vibrations, the air molecules that are bouncing back and forth to transfer the sound, hit the table, they bounce back off the table and come up into the air, and they interfere with the sound waves that we're actually trying to hear. So if you make a little case, you can 3D print it to surround that speaker on your big bad breadboard board. Well, you might not quite get the same sound as if you're using something like this, but you're definitely going to get some better sound. Let's talk about how we do this with some of our circuits and some of our amplifier stuff.
All right, so if we want to be able to understand what's going on with audio, we want to be able to build a circuit that allows us to see audio on our oscilloscope, kind of like this one right down here. I go, ooh, and generate a lovely little sine wave right there. And when I speak loud, sorry about that, you can see the amplitude really picks up. And if I speak in a high voice, you can see very short wavelengths coming through there. But if I speak in a deeper voice, you can see longer wavelengths come through there. Yeah, okay, sorry, I was just having fun right there. Anyway, right here we have a circuit that's going to enable us to do that. And you've got a handout on this. It's called the Earie circuit. And I've got it displayed just a little bit further down on the screen right down there. And we're going to go through it step by step and take a look at how to put that onto a breadboard, and then how to transfer that over to some perf board so that you've got a permanently soldered up connection. Before we do that, I'm just going to take a look at some of the common questions that get asked about this circuit, because there's a few different things on here that people might. Am I recording this? Oh, yeah, okay. I'm still recording this. At one time I started recording something and then I completely forgot to press the start button to actually start recording. Got it all set up. Carrying on. Just distracted. Today's been such a good day. I woke up, first thing I heard was that the first trials of the coronavirus vaccine actually work 90% efficient, and I'm adding this in so if I'm watching this video 5 years from now, I remember what a good day I'm having right here as we come along and talk about this. Okay, so this circuit comes in right here, and you've got a parts list on your schematic page. And because I kind of handed out the parts in a big bag of parts to you, you might have to go through and sort some things out. So I'll go through and show you the parts that I found out of my bag. And so right in here, we've got two 10K resistors. And of course, you know your resistor color code, and you have a RG tester now. So you can plug these in and you can check to make sure that you've got two 10K resistors. And one of the things that goes on right here is I just want to make a small correction to this schematic. This schematic should show a dot right here. And we need that dot to show that everything is kind of connected right at this point right here where it comes in. Um, because what we've got is we've got a voltage divider between these two 10K resistors and a capacitor just in case there's any voltage ripples. And that's coming in off of our primary 9-volt feed right here. So that comes in like this, and this takes that, splits it in half, and should give us exactly half of what we're seeing right here. That goes into our op amp right here. Now this is our TL082 op amp. And you'll notice that it's got the little dot on one corner. These ones that we have don't have the notch taken out of it. Most dual op amps will work okay in here, and you'll notice that I refer to it as a dual op amp. That's because inside this 8-pin package right here, there are actually 2 op amp circuits. So you can see right here, if I just move this out of the way for a second, we've got 1 op amp showing right here, but the other one is showing right down here. And this symbol and this symbol are both packed into that little chip. And you'll notice the pin numbering. Here's pin 1, pin 2, pin 3, and pin 4. And down on this side, we've got pins 5, 6, 7. And back over here, our power comes in on pin 8. So this is our TL082 dual op amp. And that's right there. When we go to put it onto our perf board at the end of the day and permanently solder this up, remember you do not solder chips directly onto a board, except in some unusual circumstances. You always want to be putting a socket down there first and soldering the socket in, and then gently pressing your chip into the board. Okay, what else do we have in here? Just some basic resistors, a 1K resistor, and a 1 megohm resistor. Make sure you get the color codes on that right and confirm that you've got the right values for your resistors. We've got little capacitors in here, and the schematic says U1F, of course. Now keep in mind U1F means that the U represents where the decimal place should go, so that's 0.1 microfarad capacitor, which is also a 100 nanofarad capacitor, or a 100,000, sorry. Good, I'm glad you caught that. No, what am I saying here? Oh, yeah, never mind. No, I got it right. Overthinking what I'm talking about here. It's a 100 nanofarad capacitor, 0.1 microfarad. What am I off on here? And of course, that's going to be a 100,000 picofarad capacitor, which means the number code that we should see on there is 10 followed by 4 zeros. 10 times 10 to the 4th picofarads. So if you look closely at your capacitor right there, it will say 104 on it. Same thing for this one right here. They'll both have 104 written on them. And if you plug them into your Ardu tester, it will probably report them as 100 nanofarad capacitors. Down on this side of the circuit, we've got coming out to our headphones, or, well, we don't want to run to speakers because then you'll end up with this nasty feedback loop and it'll just squeal at you. You've got 10 microfarad aluminum electrolytic capacitor. Down at the bottom here, we've got a little 33 picofarad, very tiny low value capacitor. And we've just got a little ceramic disc capacitor for that. And it should say 33 on the side of it, but I noticed that at least the ones I've gotten the parts right now, that's been stomped on a little bit, rubbed off. And over here, we've got a headphone jack, and you'll also have a plug going in right there. Now, we're not necessarily going to use the plug on this circuit, but we're definitely going to use the jack, and you'll be able to solder some wires in there, and you can plug a set of headphones into this, and it will amplify the sounds around you, and you'll be able to hear all sorts of neat things, kind of like having your bionic hearing, your super hearing. Now down at the bottom here, you could use a 510 ohm resistor, and at least this year in the 2020 version of this project, I've supplied you with a 1K ohm potentiometer, and you may need a fine little screwdriver to adjust that and get it set to somewhere around 500 ohms. And the reason I've done that is because if you flip the page over, you'll see that there's some calculations in here, and we've got another voltage divider in this circuit. And the voltage divider is a feedback voltage divider between the 100K and the 510 ohm resistor. And that controls how much amplification is going to be happening on that circuit, which will make a whole lot more sense when we talk about how, uh, how op amps work. Finally, down here, we've got U01 microfarad, so that's 1/10 the size we have right here. So this is a 10 nanofarad capacitor or a 1000 picofarad capacitor. So right on there, I can see the number 103. So make sure you know your capacitor number codes and how to read a capacitor. Finally, down here, we've got an electret microphone. Electret. I always have a hard time saying that word. And it's a special type of microphone where a lot of microphones work like speakers, where there is a diaphragm that drives a coil. This is actually more driven by capacitance. And so inside here, you've got a little capacitor, and when sound waves hit the two layers of the capacitor, they squeeze it onto the dielectric a little bit, and they change the value of the capacitance right here, which is why we've got it hooked up in parallel with the capacitor, in series with the capacitor right there to generate a signal that comes in right here, a very weak signal that's going to have to be amplified a couple hundred times before we can actually see it coming up on our DP scope or hear it triggering anything on our headphones. So this is going to take all that. Now, one of the things you do have to know about this little electret microphone is that it does have a positive and a negative side. And you can see on here, I've marked which is positive and which is negative. But I'm going to zoom in right here on this so that you can maybe see in more detail. And let me get a good focus right in there. How do we know which is positive and which is negative? I'm zoomed all the way in. There we go. Okay, now when I zoom all the way in on that, let me grab just a little piece of wire right here. You'll notice that on this side of the microphone, there is a little solder trace that connects this pin to the case. Okay, and on this side, although it's very close, you don't see that right down here. Here we are actually connected to the case. And the case of the electric microphone is grounded. Okay, in that case, what that means is that if you bump it into anything else on your circuit, you don't have a problem because the case is already at ground. So this pin right here with a little line coming right in here is your going to be your negative side of that mic, and this is going to be the positive side right here. It'll probably still work if you get it backwards, but try not to do that. And to help me remember to keep that sorted out, I just took a felt pen after I'd finished up on there and added a little marking for a plus minus on there so I could find that again if I had any problems. So get your parts sorted out and then get yourself a breadboard. And let me zoom out a little bit here. Now you don't have to start with a blank breadboard. We're not going to use up very much space on a breadboard. In fact, this only takes about 10 or 11 rows. But I do want to show you a little bit about how I've hooked this up to give us proper power. Now this circuit is going to require 9 volts driving it. We're not going to be able to get away with just drawing 5 volts off of our Arduino. And that's got to do with some of the nature of what we're doing with the op amp, how the op amp itself works, and what we're trying to get as an output signal. So I've replaced the little battery in here with a 9-volt battery, but you don't have to do that. because of course you've built a power supply, so you can draw 9 volts off of your power supply. But if you want it to be portable, this little clip is perfectly capable of holding a 9-volt battery. Now, down at this end, I've taken some of the parts that we had in our Big Bad Breadboard bag. And let me just zoom in right here and show you what I've done with them. Okay, so the first thing I've done is I've taken my battery clip, and rather than just using the little wires that go to it, I've done a crimp connection to this amp connector right here and put that in there, and used a couple of the dual-headed header strips, the dual-ended header strengths with a double length, to fit that right into there so that I can push that on and have it stay in there nice and tight. Now, right in on this side, I've put a switch, and that switch enables me to turn the power off and turn the power back on without having to plug and unplug things. It's perfectly fine to plug and unplug things, but it's sure a lot nicer to have a little switch doing it. So all the switch is doing is it's connecting what's coming in on the positive right here. When I slide the switch this way, the positive connects to right here. And then I put a diode coming over to our positive line on the top half of the board. And of course, we've got ground coming in right here from where the ground line comes in. So this is going to enable me to get a diode protected 9-volt signal. Of course, it won't quite be 9 volts because we will have a small voltage drop in the diode of about 0.6 volts. So we'll be about 8.4 volts or so coming in right here. Now, the other thing that I've done right here is I've connected ground on both sides of the circuit. So this set of 5 holes right in here is grounded, and then that comes to this line right here, and that's grounded. So both sides of the circuit are grounded. But what I've also done, there you can see where it comes through right there, is I've been very careful to make sure that my Arduino is only hooked up to this side of the circuit. So in the past, I may have had a positive 5 coming across here so that my Arduino can power both sides of the circuit. If I do that, then I end up with my 5-volt Arduino getting hooked up to the 9 volts on this side of the circuit. So you can leave your ground line in here if you've got one. It's okay to connect the ground lines because they're at 0 volts. But on this side of the circuit, you want to have a 9-volt rail, as I've got up here at the top, and a 5-volt rail, as I've got down here at the bottom. Now, a couple of different ways you can get that 5-volt rail down at the bottom. And one of the ways, of course, is just by plugging in your USB and having the Arduino provide power to the circuit from USB. Another way that you could get that 5 volts is by plugging a power supply into your Arduino, because it does have a socket to put say a 9-volt power supply in right there. It's got right on the socket, it's got on the Arduino, it's got voltage regulators and capacitors to filter and regulate that voltage. So the Arduino can supply 5 volts to your 5-volt line, but it can't supply 9 volts to your 9-volt line. And what I've done down here is just another way to supply power to your circuit. I've put the 7805 linear voltage regulator in right here. And so this lets me run everything off of one battery. And what's happening now is that power comes in right here. There's my power. There's my ground. It comes to this switch right here. When the switch is thrown to this position, this pin right here that has my power gets hooked up to this middle row of the switch, which connects into these pins. There's that diode that goes off to power the board. And here is the 5-volt voltage regulator line right here, so that when the switch is on, the 9-volt battery also comes down here. The The 7805 voltage regulator has its pinout being input, ground, and output when you're looking at the front of the regulator. So you can see right there, it's got a little notch right here, it comes up and around like that. The number is written right across here in the front, even though you might not see it in this video view. And so starting with this pin right here, that's my input. So I can take any voltage from about, say somewhere around 7 volts up to about 18 volts, depends on how much current you're drawing. That'll come in right here. And relative to the ground pin, your output will come out at 5 volts. So coming off of here, we've got this hooked up so that the ground pin right here, no, I haven't hooked my ground pin up yet. Well, there's going to be a lot more convincing demonstration when I hook that ground pin up. That ground pin should be hooked into ground, and it should work a lot better after I do that. In fact, it's working right now, but I really don't know why. Anyway, add ground right in there. So this is how we set up our board. And like I say, you want to have 9 volts across the top. Now you can skip over doing just about all of this right here, so long as the positive supply from your Arduino is only connected to that bottom rail, okay, right here, and you've got no red lines going from this red header up to this red header. Okay, because this one up at the top is going to be at 9 volts. This one's going to be at 5. You don't want to feed the 9 back into the 5. That could end up damaging your Arduino. Not to mention the computer's USB power supply that's hooked up next to it. So be very careful how you're hooking this up when it comes to power. We need the 9 volts. If you want to skip past doing all of this down at this end, well, you do have a power supply, and you can plug 9 volts in right here and ground right there. Just you won't be able to take it along with you because you'll need to carry your power supply instead of having a nifty little battery just clipped in right there and being able to shake it around and have your power go with you. You'll know it's working if your Arduino's blinking right there, but before we do anything else, let's just zoom out a bit right here. And I do recommend that you take a multimeter and double check what's going on in there. And just take your multimeter and choose ground on one side, positive right there. Oh, there we go. I'm getting 5.7 volts. 5.7 is fine. Up at the top, I'm getting 8. Perfectly fine. Means that the battery is probably a little dead. You can check your battery voltage right there. 8.37. Yeah, that's a little low for a 9-volt battery, but it's still working. And of course, coming off your 5.76, that'll probably go down to exactly 5 as soon as I connect that ground line. Okay, I'm going to do a few things right now, and we'll be back in just a moment. I've got a ground line to connect up. Okay, well, we ran into a couple of technical glitches there, but thanks to the magic of video editing, you have been spared watching me struggle through them. And it's just taken a little bit of time, but we're going to get this all sorted out. And if you see down here, everything seems to be working again. So let's see, we've got our chip in here, the TL082. And we've paid attention to where that little dot is or where the notch is, depending on when you get it, because that indicates pin 1. We've paid attention to our pin counting, 1, 2, 3, 4, 5, 6, 7, 8. Why did I put the chip in this way around with the 9-volt line up on this side? No particular reason. That was how I did it the other day when I made my first sample of this circuit, and it seemed to work out okay. So I thought I'd do it this way for you. I think there is a little bit of efficiency to be found from swapping it around 180 degrees this way, but this does good enough for what we're looking at. Alrighty, so I've blown up the image of the schematic here because there's a few interesting things going on in this schematic. Now, right up here, let me grab a red pen, and it doesn't need to be very big, but let me grab a red pen. We've got our 9-volt supply coming in this way, and we've got a diode on there. Now, earlier in the video, I talked about our switched power supply, or our switch for the power supply, and adding a battery so that we'd have a switch and a diode coming into the circuit. So this is our 9-volt header running right up here. And you can see our 9-volt header comes along right here. It comes down to pin 8. We'll hook that up shortly, but I've got a few other connections to make first. And it comes over here, and it's also going to connect up to a pair of resistors in a voltage divider style circuit right here that are going to feed into the non-inverting input of one of the two op amps right here. So that's kind of up on the positive side. But really, before I even go and hook all that up, I'm just going to undo some of that. And there's our 9 volts coming in. That takes care of the diode. How do I go about wiring a circuit like this and deciding where to begin? And it kind of depends. Sometimes I like to start at the top and work my way down as I flow through the circuit. But when I've got a chip in here, I like to make sure that I've got each of my pins hooked up correctly. So I'm actually going to start on my op amp right here, and I'm going to go around one pin at a time and see how far that gets me as far as getting the whole circuit hooked up. So my starting place is going to be right here at pin 1, because may as well start with pin 1. And if we look at pin 1 right here now, pin 1 is the output from this op amp, which is going to make a lot more sense after you watch the video that I have yet to record on how the op amps work. But anyways, now you'll have good questions for that. You'll see that the first thing that pin 1 does is it comes right around and hooks right back to pin 2. And because I used a purple connection right in here, I am going to use a purple mark right here to indicate that I've got that hooked up. Okay, good. We're still recording here. I clicked on the wrong screen by mistake and have to find the right screen. There we go. Purple line. So that pin 1 comes down. With the highlighter, I come right around and run that right into pin 2. So that was a really easy one. Just do a nice job. Drop it right into the line there. And you've got pin 1 hooked up to pin 2. The next thing pin 1 does is it comes out here. Now this is our output from this op amp, and it forms what we call a 4.5 volt reference for the circuit. Now that's significant because we've got 9 volts coming in up here, and 4.5 volts is right in between 9 volts and ground. And so if you think about a audio waveform and say this is our 0 volt line and an audio waveform going above the 0 volt line and below the 0 volt line, okay, our 4.5 volt reference is actually going to take the place of that 0 line. So we're going to be able to go above it and go up to 9 volts, and we're going to be able to go below it and come down to about 1 volt. And in order and having that work at rest, it'll just sit right here at 4.5 volts. And so we're going to be able to move our speaker diaphragm forward and backwards as the audio waves demand. So it's important to have that 4.5 volt reference right in there. And once we get that 4.5 volt reference, it goes out to a number of places. It goes to anywhere on the circuit where you see a 4.5 volt reference marked in. So right down here, it says 4.5 volt reference right down here. Well, that means that these two are actually connected to each other. So you can picture a little line coming from right up here and running all the way down here on the back of your circuit and saying, hey, these two are actually connected. Nice drawing there, Jason. So, so we've got these two connected because of the name on them. And this is the exact same technique that we use when we write +9V or if we use the ground symbol right here, everything that's got a ground symbol is connected to everything else with a ground symbol. Everything that says 4.5 volt reference is connected to everything else that says 4.5 volt reference. So ultimately, we're going to end up hooking up pin 1 to either a 510 ohm resistor, or in our case, this year I've given you a potentiometer. We're not going to do that just yet. We'll wait till we get down closer to the pin 6 side, because I don't want to complicate some of the things that we're doing right in here. But there's more coming. Anyway, what I want to take a look at is the 1K resistor right here and the 1 meg ohm resistor right here. And you can see that they are connected to pin 1, and pin 1 it comes right down here and here on these sides. So what we've got right here, this is pin 1 coming out of the circuit. We've already connected it at pin 2 with that little jumper right here. We come in right here, and there's your meg ohm resistor on the inside and your 1K ohm resistor on the outside. There's another way of folding over the resistor leads so that they actually go up vertically and then jump down to the other side. I might show you that trick later on if I haven't shown it to you already. This is not a jumper right in here. This is our little 104 capacitor, because that is the U1F cap right down in here. And it's connected to a slightly different line, but I've put it in already. And there it is right there. So that comes up and connects to those two. And then we're going to take some lines off of here and do a few other things with that. Okay, so we've got that hooked up right in there. Pin 1's looking pretty good. You can always come in here and you can count. You can say right there, I've got 1 connection, 2 connection, 3 connections marked off. And then you come to your board and you say, well, there's 1 connection, 2 connection, 3 connections marked off. And we've got room for our 4th connection, which is going to be that 4.5 volt reference. And later on, we're just going to run a line down here to jump that over. Okay, so that's all hooked up and running right in there. Let's move down a little bit. That's pins 1. Pin 2 only has 1 connection on it. We've checked that out already. So there's pin 2. There's only 1 thing in that set of holes. If there's more than 1 thing plugged into that set of 4 holes, you've probably got a problem. And the 1 thing that is plugged in there goes back to pin 1. So that's all good. Let's take a look at pin 3 now. Now keep in mind that this connection at pin 3 between the 2 resistors, there is a join right there. So we've got a resistor that comes in from the high voltage line. Not that 9 volts is particularly high, but it comes in right here. So one of our resistors is hooked up to 9 volts, and the other resistor is down here, and it's hooked in to ground. And then we have a capacitor between ground and that line, and that's all connected into pin 3. So let's see how we did that right on our circuit. All right, well, I am just having a bit of grief today with the computer hardware for some reason or the other. Anyway, you're seeing an edited version of this that has all my swearing out of it. So we just finished hooking up a voltage divider circuit, and I think we mentioned that this little capacitor right here, this is a capacitor, not a jumper between them. We wouldn't want to jump between those 2 pins and ground. This little capacitor right there is one of our 104 100 nanofarad U1 capacitors. And then the next thing we're going to do is I'm actually going to jump ahead to pin 8. Before we do, I got to finish marking this up a little bit because we have got some more things done in here and they didn't get marked up during the last crash. That wasn't the button I wanted to click. This was the button I wanted to click. Okay. So in here we came in and of course the wrong screen pops up here. Okay, we came in here and we marked up right in here. Let's pick a different color and let's just add a bit of green. Pin 3 has lines coming to a capacitor, and you can see the capacitor on pin 3 right there, the little blue one. And then it's got connection to a 10K resistor going to ground and a 10K resistor going to positive. So there's the one going to positive. There's the one going to ground, and that's the positive 9-volt line. So when you get the voltage divider between those two, because they're the same value, you'll get 4.5 volts coming in on your input right here, and then your output right here comes back and feeds that into the inverting input, meaning that the capacitor, or meaning that the op amp will always be trying to put 4.5 volts out right on that pin 1. And then pin 1, of course, comes out to these resistors and this capacitor that we talked about earlier, and we're keeping this all marked off on our chart as we go along. Now, just so we can do some testing at this point, I know I've done pin 1, pin 2, pin 3. I'm going to do pin 4 and pin 8 right here just to wrap up this side. So pin 4 goes directly to ground. And so we'll just put a wire in right there for pin 4. And somewhere here I have a little jumper ready to go to ground. Make sure everything's still working here. I'm just going to pause and put the jumper in for pin 4. Turns out I had put in the jumper for pin 4. I just hadn't put it to ground yet. That's the pin 4 jumper right there. So I'm actually going to take a look. I just hadn't marked it off on my chart yet. So right in here, I needed to mark that off because as you go through a complex schematic, if you can kind of mark it off as you go along, it's a lot easier to follow. I'm also going to come in here, and now I'm going to add pin 8 right in here and mark that up. I think I was using this pen to do my pin 8 marking. There we go. And so pin 8 is all the way right over here. And so I'm going to take a little wire and very neatly run it right around here and over to our 9-volt line. And of course I can't connect to the 5-volt line because I want this all to be powered by that 9-volt supply for this part of the circuit. And you'll notice I'm keeping things down neat and flush to the board as I go along. I know there's a few people out there just like, oh, it's such a pain to go and cut everything nice and neat as I go along. But really, you'll find that it pays off at the end. Now, what we can do right now, and let me just zoom out a little bit here, is if you've got this all wired up and you've got 9 volts coming to your board, then we can do a couple little checks right here. And so bring in your multimeter. And if you don't have a multimeter, your DP scope pins can do it because there's a voltmeter mode on your DP scope as well. But I've got a multimeter sitting right here. And let me just move that up so you can see the screen a bit better. And all I want to do is I want to check and make sure that that 4.5 volt thing is working. So start right here. And anytime you go to analyze a power supply, what you want to do is check to make sure that you do have a power supply. Helps if I turn that on. There we go. You saw the little lights on the Arduino come down there. That's a positive sign. And yeah, that battery's really, well, it's not that dead, I guess. It's still giving me 8.5 volts, but by the time we account for the voltage drop in the diode, I'm seeing 7.87 right there. That means on pin 3, I should see half of that 7.87. So 3.9 makes sense, and I can check both right where the voltage divider happens, right in here, and also at pin 3 itself to make sure that pin 3 is pushed all the way down. Those should be at the same voltage outputs. And then I should be able to come along over here and check on pin 1, and I should be able to see that sign right there also being at exactly half of what I'm putting in right here. Okay, so that's a good little troubleshoot to make sure that you've got your first op amp all hooked in and working properly. And now we're going to go through and we're going to look at pins 5, 6, and 7 and the microphone itself and how we hook up the rest of that op amp. Okay, let me turn that off right there, get it out of the way, zoom back in on our circuit a little bit. There we go. And just make sure that's pretty nice and focused. Okay, So now we're connected up to this point. Well, this connection right here coming off the 1 megohm resistor looks like a fairly easy one to do. It looks like we want to take that and just take that into pin 5. So I want to run that into pin 5 right there. And that will just take a little jumper to come down and around the corner from the 1 megohm resistor. So that jumper is going to come off the 1 megohm resistor that comes off pin 1 right in here. On the other side of the capacitor, we're going to come down here, and we are going to come down to pin 5 right in here. Looks like a nice place to plug that in. In fact, we can probably plug it in right in there. Okay, so I'll just put that in and check it off. Okay, I've added a few things into the circuit, and so we were going to connect the 4.5 volt the resistor that comes off of the 4.5 volt reference. This 1 megohm resistor right here comes to the capacitor right here. That was already in place. I've added this orange line that comes down around here and connects that into pin 5 right here. And I've also added this yellow line right in here that comes in and connects to our electret mic. So I'm just going to use a yellow highlighter to mark that off on my schematic and show that that is done. So the yellow highlighter representing the yellow wire is going to come in and fill in this line right here from the capacitor and the 1K over to the positive side of the mic, and we'll add that 1 microfarad capacitor, that 10 nanofarad capacitor in there in just a moment, but there you can see that yellow line connecting right there. Now, like I say, it was important to get the positive side of the microphone. We marked the positive side off earlier, so we've got a plus minus on it. And as you'll recall, looking at the bottom, the positive side is the side that doesn't have the little connection to the outside of the case. And just be really careful when you're lining that up to make sure that you get everything lined up in there nice and straight. Okay, now the ground side of the microphone is going to be located in this hole right here. And so that hole is going to have to come back to ground. We need to put a capacitor in there. So since I didn't leave myself any space down on this side, just because of the way the mic is laid out, I think it's going to be a little bit neater to come in here and just run this down to ground. We could run it down to ground on the other side of the board as well. In fact, you know what? That is going to be the neater way to run it on this board. I think that's actually going to be easier to read and easier to understand is if we jump that right across to there and just take that, and I'll mark that right there for a little bit of stripping and strip that off. Trim those leads down to about 1 centimeter. Let's see if I got that fit just the way I want it to go. So that one plug in right there. Plug in right here. And get that down so it sits nice, straight, square, and flush onto the board. So that shows that the ground connection has been made right in here. Let's mark that up with a little bit of black so we know we've got it done. Okay, and now I need to find that 10 nanofarad capacitor and put that in there between this connection right here and right there. So grab my 10 nanofarad capacitor. It's going to be just a little bit big to fit in there. It would like to fit across 3 holes. So what I'm going to do is just take the needle nose pliers and give this a little bend to bring it in like so, and give it a little bend to bring it down. like so. So you can see I've kind of tucked those leads in so that they're going to fit a bit nicer. And then we'll just trim that off. And pop that in. You can see the two holes that I'm going in there are right across. We've got our ground line on one side, and we've got our positive of the of the microphone on the other. And there we can slap that in right there. And now we can say that we've got this connected, we've got this connected, we've got a capacitor in between these two. They connect into pin 5, and we can start moving on to pin 6 over here. So pin 6 is going to come down this way, and let's pick a color we haven't used. Pin 6 is going to come out right in here, and it's going to connect to a 100K resistor, and it's going to connect to this 510 ohm resistor that goes back to our 4.5 volt reference. It's let's do the 100K ohm resistor first, because that comes around to pin 7. Okay, so if that's coming around to pin 7, my 100K ohm resistor, well, pin 6 to pin 7 is a pretty short trip. So what I'm actually going to do is fold that resistor's leads over and snip it down, and it's going to look about like this as I go to put that. Let me hold on to it with something a little daintier right there. So it's going to look about like that as I go to put that into the circuit, and that's going to allow me to slip that in between pin 6 and 7 vertically. And I'm just going to put that right down here. So there we go. It's a standing up resistor. Good way to tuck resistors in if you need to do it in a really close sequence. And then in parallel with that, we've got a 33 picofarad capacitor. And that's going between pin 6 and 7. That little capacitor probably just needs a little bit of a trim down on its leads. And there we go. That's right in parallel. Also going between pin 6 and pin 7. So now we've already started doing some of the stuff on the pin 7 side. So the pin 7 stuff that we just connected right there is this section right in here. So now we can put a 10 microfarad capacitor in right here, and that's going to come off of pin 7, and that's going to go ahead and provide us with our output. Now I'm going to arrange for the output to come out right down here somewhere so it's not sitting over top of the microphone. And to do that, I'm just going to bend a lead on a capacitor right here and see if I can run that through nicely and neatly from pin 7. Down to a different hole. So this is going to go into pin 7. I bent that a little bit longer than I need to, so I'll come back and shorten that up. And like I say, it does take a little bit longer to do it nice the first time out, but it sure takes a lot less time to do it nice the first time out than it does to try and fix it later on. And so I'm going to put that in right there, making sure that I'm going both into the hole on pin 7. So 1, 2, 3, 4, 5, 6, 7 comes in right there. Okay, and then the other end of that capacitor, the negative side, shows the negative side of the capacitor should go into pin 7. Pay careful attention to that rather than watching your own video feed. That fits a bit tighter in there. If I had a chance to go back and do that over again, I think I would have bent the positive lead up, but it seems to be fitting. You do want to pay attention a little bit to make sure that you don't have components bumping into each other. So this orange wire is insulated. This is an insulated part of the resistor. I don't want the case of my capacitor touching up against that bare resistor lead that I've got tucked in right there. So maybe once I'm done filming, I might actually go and replace that capacitor and flip it around so it goes in the opposite direction. But whatever, it's not a big deal right now. It's in there. So we've got this connected in here as well. So the thing that we have left to do now is going to be right down in this section, this 510 ohm resistor. And we could put a 510 ohm resistor in there, but what I've got for you instead is a potentiometer. And the potentiometer is set up so that we can use it to control the resistance that is part of the voltage divider between the 510 ohm resistor and the 100k ohm resistor, so that we can control the gain on our circuit, or the amplification that we get off that circuit. So what I'm going to do with that is just take this right here, and one side of it needs to go to the 4.5 volt reference, and the other side is going to come around to the side of the board. I'm going to plug it in over here, and you'll notice that my first hole that I'm using has nothing else in it, so all three of these holes are disconnected. And actually, it's going to make a nicer jump if I move that little capacitor out of there and just put it into that hole right there, because now I have a clean line over to pin 1, which is my 4.5 volt reference. So why is it pin 1? Well, if you follow this gray line that I sketched in around here earlier, did a lovely job on it too. If I come all the way around over here, my 4.5 volt reference connects up directly to pin 1. So I'm going to choose a color that I haven't used before for my wires. I've got some green sitting around right here. And I'm going to drop that in, make sure it goes in exactly to pin 1 right there, because we've left a little space for it. That lead was just a little bit too long. I'm going to shorten it down into pin 1. There we go, all the way down. Nice 90-degree bend in there. And then I will mark off where I want it to stop, which is about right there. Give myself an extra centimeter or so of wire, and then strip that down, bend that around, and come back in here, and one end on pin 1, the other end into one side of that variable resistor. And like I say, you could replace that with a 500-ish ohm resistor in there, because it's the link between this resistor and this resistor that creates a voltage divider that controls the amplification. On the other side of that resistor, we have to bring it all the way around over to pin 6, so it's plugged into pin 6, and you can see we've got a little bit. Pin 6 is getting pretty full, but there is a tiny little bit of space to plug something into pin 6. If I carefully wiggle this orange wire up and out of the way, I've intentionally left enough bend room on there so we could do that. And there's a hole coming off of pin 6 that I can drop a wire into and bring that around. So I'm going to use, another color that I haven't used right yet. May as well use the light green, seeing as how I had dark green going in right there. And we'll come doing this in real time as we go along. It doesn't take that long to do a nice job of your wiring. It's a little too long. Knock a couple millimeters off. Fit that in nice and flush. Bring it around right here. hold it with the needle nose pliers so I can bend it exactly where I want it to bend. Get a nice sharp bend in there. Make it look like I'm trying to be neat. And then that's going to come to pin 6, which is going to be about right there. Okay, take that. Give myself a centimeter or so, maybe 9 millimeters to plug into the breadboard. Strip that off. Make sure that end goes into pin 6. Holds over nice, doesn't touch anything that's live on the capacitor. And of course I'm bending it all in a different way now, so bend that around. I'll share my last wire of the board and I'm going to make it look ugly or something like that. There we go, that's not too bad. Oh geez, it's almost 90 degrees in there. There we go. That looks pretty good and square. Okay, so the speaker, the audio is now going to come out at this point right in here. And for our purposes, we're going to connect to a headset using this little plug headphone jack right here. But since you've got a DP scope already, what you can do is you can grab a resistor. And here I'm just going to be slack because this isn't going to last for a long time. And right between there and ground. Okay, look at that. Isn't that delightfully ugly? Because I know that one's going to be temporary. And what you can do is you can take your DP scope and plug a couple wires into your DP scope here. One of them is just going to plug directly into ground. There we go. Actually, I've already got a place where I can measure a wire going into ground. There's one right there. And then you can view the audio coming out right on here. And this is going to be interesting to see if I got this circuit all done correctly. So I'm measuring the voltage across this resistor. In reality, these would be our headphones, but if we see a voltage going across them, then we should be able to see some audio. So let me bring that down. Say, where the heck did my DP scope board go? That's just hold on a second. Hey, there's my DP scope window. I can see sound again. So this is now the sound that's coming in, the sound waves off my voice. To make this a little bit more visible, I've turned off channel 2 and I'll make my lines go bold. That makes it stand out a little bit better. There's a check mark up in the top corner of the screen right there. And they're still pretty flat right here. And that's because we're on a 2 volts per division scale. We can actually go down to 0.2 volts per division. And now you can see that they've moved way up off the middle of the screen. And that's because what we're reading is all centered around the around that 4.5 volt reference. So to recenter that on your screen, just reposition channel 1 down to the bottom of your screen right here. And now your 4.5 volts is running right across the middle of your screen. And as you talk on the screen, you can see those sound waves coming in right there. You can play around with the precision of that, of course, but the real technique is now you can come along, and if everything's working well, you go, and generate a really pure sine wave in there. Now, if you want to be able to capture that and see it, turn on triggering from channel 1 and set your trigger level up to somewhere right about in here. So it only triggers when a signal gets up past there. So you need to have enough volume to see it. And then go, and there you go. You'll capture that sine wave right in there. And honestly, this is a frighteningly pure sine wave. It's really, really good. So I'm sorry you had to listen to it. But what we're seeing right here is, oh, I spoke too loud and it's capturing new things. Every time my voice comes along here and gets a little bit louder, I am going to freeze that in the screen this time. Just a minute. And click on this little red arrow right up here, and that will freeze it into reference 1. Then I'm going to turn my trigger back to auto so my sound just keeps bouncing around. But we'll still have this signal in the background. And you'll be able to take a look at that and time how long it takes to go from peak to peak. So if this is one peak right in here, and I'm at a 0.5 milliseconds per division scale, so that took 1 millisecond, 2 milliseconds, 3 milliseconds, about 3.5 milliseconds to go from the top to um, uh, to go from peak to peak. So if you go 1 divided by 0.0035, that was a 285 hertz sound that I was producing right there. So there you go. Your board is working, and we'll talk a little bit more about how to hook up this lovely little device later on. But you should be able to see your signals on the DP scope and have a working board. Yay! Ooh! Can I match that tone again? Ooh! Ah! How deep can I go? Oh! Okay, I'm just playing now.